Hi. Hi, guys. I think it's dot time, so we'll get started. So the session is about SIG-Multicluster. We'll be covering the intro and the deep dive. So the time allotted is pretty long, but we'll try to keep it short, being the last session of the day. Our target is to finish it in approximately 45 minutes. My name is Irfan. I have been associated with the Federation work group and the Federation project since a couple of years. And with me, Maru from Red Hat would be giving the deeper dive of the session. Okay, so agenda for today is we'll be reiterating the mission. So the same has been covered a couple of times in previous intros and deep dives. But I'll just reiterate it for folks who might be new. I see many new faces, which I didn't see in the last KubeCon. And then we'll talk about the active projects that we have as part of the SIG. So we have a cluster identity project, which is running. And we have a Kubernetes Cluster Federation project, which has been there since almost 1.5 to 2 years, pretty active. Then we'll talk about what we have been doing in, from last KubeCon till now, last 4 months. And then Maru will deep dive into the Cluster Federation concepts, probably a little bit of how and what's the suitability of the same and how to use it, that kind of stuff. We will try to keep a good amount of time for some interactive discussion if there are questions. So this is the mission of SIG-Multicluster is available at our community page also, but just reiterating that we are the SIG who are concerned with the use cases of concerning with management of applications and which lie in multiple clusters and their administration across the clusters. So we have implemented some active approaches. Kubernetes Cluster Federation is a typical example of that. But we do not limit ourselves in terms of the goals of the SIG, saying that that's the only approach that we want to take. So we do keep our scope tackling problems relative to the approaches of, approach of standalone GitOps model or Spinnaker kind of models. And we do not have any active work going on them right now, but we say that we do not limit our use cases to an active reconciliation model only. So this all information is available at the community page. The link is at the bottom of the slide. You are encouraged to have a look if you are interested more about it. So I mentioned we have 2 active projects right now. So one is the Cluster Identity project. The other one is Kubernetes Cluster Federation. So a little bit about Cluster Identity project. The goal of this is to define a cluster identifier, which is sort of more durable than a cluster endpoint, or just the IP with which the cluster could be identified, or a cert with which the cluster could be identified. And the need of this has been there since some time. There was some effort or some initiation around this, which happened in the Kubernetes core almost 1.5 or so year ago. But it was stalled for various reasons. It didn't conclude. The use cases for this is like any cloud provider which has multiple clusters, which needs to manage multiple clusters, need to identify the clusters with something. And for example, if a cluster goes down or a cluster is taken offline and then it returns back, the provider, all the users, both should be able to identify that cluster, that it's the same one which I was interacting earlier. So API endpoints change, certificates change, everything's changed, but probably the durable storage, probably the resources inside the cluster or something that was stored in the cluster does not change. So this effort is around that. And the status of this is that the effort was kick-started almost, say, a month or a little more than that ago. And it's the initial discussions that are happening, and it's more in sort of brainstorming and design phase kind of a thing. And this is very actively being discussed in our bi-weekly sync that happens on Tuesdays. The details of the meetings are available on our community page. The second sub-project that we will be talking about, and that's what we'll be actually talking about in the rest of the session, is CueFed. And if you noticed, I used the word CueFed for cluster federation. So there is a history around this. So federation was initiated as part of Kubernetes core a couple of years ago, and later there was a drive that we should keep most of the not necessarily core relevant portions of the software outside the Kubernetes core. So we moved out of that, and we used to call that Federation V1. We redesigned or re-implemented because of various reasons. All the reasons were covered in previous KubeCons, and there are slides and there are talks available for that. So the next name that we have been sticking till now has been Federation V2, but Federation V2 does not sound like necessarily a good name for a project like this. So we officially renamed it to CueFed a couple of probably weeks back. And so it's short for Kubernetes Cluster Federation. That is what we are using as the official name for this. And that seems to fit well. It also does not give ambiguity where the federation as a term we felt was ambiguous when it was used sometimes outside Kubernetes scope also. So federation could mean a lot of things. So we wanted to disambiguate ourselves from that too. So we also had a configuration tool which we named CueFed earlier. We have renamed that to CueFed CTL. The project right now lives at this link, which is at the bottom of your slide. And we have a vanity URL also, which we call sigs.ktest.io. And so what ideally a user might want to use CueFed for? So we have pointed out use cases. We have listed down what is Federation useful for. And I'll give one more disclaimer because this name change has happened recently. So both of us might interchangeably use CueFed or Federation, but we mean the same thing. Okay. So so the definition of or the utility of the project CueFed we say is if a user wants to have or coordinate configuration across multiple clusters. By configuration, we mean the K8s API. It could be CRDs or it could be actual K8s resources. But if the same stuff across multiple Kubernetes clusters, that could be in any number, needs to be coordinated and managed from a single API surface, this is a typical solution for that. This solution also includes active reconciliation. So in the slide where I was talking about the mission, I mentioned that we do not limit ourselves to an active approach, but this particular project implements an active reconciliation approach, and it basically pushes the needed configuration to the needed clusters. It also defines, let's say, foundational building blocks. So our implementation right now is quite low level, and we define low level concepts of achieving this kind of implementation. So what we say is this is perfectly suitable for folks who want to build high level stuff. For example, a scheduler, which is in multi-geography kind of a scheduler, or a disaster recovery mechanism. That means a higher availability application which can be placed in multiple clusters and automatically managed in terms of in case a cluster goes down or a problem happens with one region or one cluster. So where we are at, since last KubeCon until this KubeCon, our efforts have been to ensure that we at least define some portion of the project and say that we are able to beta support it, or we are able to say that this portion of the project is beta and we'll be supporting it. So we have been driving towards that. And our goal is to probably reach somewhere with respect to that by this KubeCon. So yesterday we released a release candidate for beta. And there are a few outstanding issues and some documentation updates. Given that, we should be able to reach beta soon. And one of the reasons we have been driving towards this effort is because until you say that the project is an alpha, there is very low chances that you get user or the community feedback. So one of the main reasons we want to claim beta is that we actually get the community feedback, users have some faith on it, and they use it. So yay, we are able to reach that milestone very soon. OK, so next would be what we have been doing since last KubeCon, say, in last 4-5 months. To showcase that, I'll start with a demo, a small demo, where, so as part of the demo, everybody would know about, say, K8s applications. So they are like resources. You might have a config map. You might have a deployment. You might have XYZ resources. Application can comprise of many of those resources together. So we are taking a simple application. So then what we do is we can deploy the CubeFed control plane in one of the host clusters. So it is a CRD-based API which can be deployed in one of the clusters. And that cluster is our host. Then we say that we need to enable a federated type. There'll be more details Maru will cover about what exactly is this enabling a type and what does it mean by. I'm skipping that for brevity right now, those 2 steps. And what I'll do, I'll deploy a normal K8s application, and I'll try to make it a federated application, and then show you what can be done with it. OK, so let's start with the demo. So I have already deployed a control plane, and there are 2 clusters joined to that control plane. So what I'm doing is, in one of the clusters, I'm creating a namespace, and within that namespace, I'll be creating a couple of resources, which I'll be calling it as a simple application. So let's create a namespace. Then creating some resources. So I'll create a config map.
Can you pull your window? Because it's clipped off the screen.
Oops, sorry. Seems fine? The font size is fine? Yeah, I think it's legible. OK, so I create a config map. Then I run a deployment. It's created. Then I create a service. So these 3 things I call a simple application. So there's a config map which has a string which has a string stored in a file which I mount inside this Nginx deployment, and which can be retrieved on a web page or which could be curled from command line. So after I created the config map, if you see this step, this is CubeFed CTL Federate Namespace. So the name of the namespace is demo, and a couple of other commands. One of the specific flags is ---- content. So what I'm doing is, what I'm saying is I am sort of federating this particular application using one command. So it's as simple as that. So I have right now created a federated application. So I have sort of up-converted whatever application you have in a K8s cluster, and I have created a federated equivalent of that application in the Federated API Surface. Suppose that I'll show one of the resources. So we had 3 resources as part of the application. There was a config map, there was a deployment, and there was a service. So we'll just fetch the service. because it's a lesser than, I mean, the overall content of that is lesser than compared to others. So if you see, this is the federated equivalent of a K-test service. So we call it, at the top of your screen, we call it a federated service, and what it wraps around is the K-test service itself as part of the template. So in the federated service, you have the template, and that template basically has the spec of a K-test service. So it's as simple as that. And additional to that, we have a placement, and there is another concept which Maru will talk about, that's an override, which is missing from that right now. We are not using override, but if it is needed, I'll show you how an override can also be used. And if you see here, this is also showing the status, which we call the propagation status. So it's basically telling us, without going and looking into individual clusters, that this particular resource has been propagated to these 2 clusters, and it also is telling us that the propagation has been fine and there are no problems. So if there were problems, the problems can also be reported here as part of the status. Let's move ahead. So just to be double sure, I'm querying the same application from individual clusters. And what we are doing here is, because this is an application, I'm doing a curl for what exactly this application returns back as part of the web page. So there's the first cluster. So it's a simple string that it returns. In the second cluster also, we can find it's returning the same thing because our propagation mechanism has just replicated the same resource in both clusters. So if there were, say, 10 clusters or 20 clusters, the exact same mechanism will be followed, and the resources will be replicated across all the clusters. This is a default placement mechanism. So in the second cluster also, we get the same thing. So we have the application running across 2 clusters. Now these clusters could be in any geography. If the control plane is able to reach those clusters, it'll be able to coordinate the application across. So next, what I'll show you is, I mentioned about overrides. So we have a mechanism. So some of the basic tenets of this is that we say that we have a template, which is nothing but the spec of the target resource, placement and an override. So some mechanism we define placement, some mechanism we define the override, such that placement says that the resource should be sent into these particular clusters, and the override specifies that within a cluster, within a resource, if you want to change something, you can specify that using an override. So let's see how override works. So what I'm doing is, if you see at the bottom of your screen, the command is, I'm patching federated config map. So that config map contained the particular string which we mounted inside a file in the Nginx container. I am just changing it to hello KubeCon. And I am also saying that change this for cluster 2. The last line on the screen on my right-hand side, it will say that we are changing it in cluster 2. So when I query it from cluster 2, I should be able to get this string once it is updated over there. So the file is patched. So it takes a little while because it's a complete loop that goes on. So there's a reconciler which reconciles this into the resource, and from the resource it is mounted into the Nginx pod, and from where it is reflected back on the HTTP curl or the web page. So this is cluster number 1. We still have the same query string. Cluster number 2, we are already able to get that it is updated and the Nginx application is saying. So overriding something inside a resource was this simple. So you specify for a cluster what is the value you want to specify inside a resource, and you specify that's the path of the value of the key, and it can be updated. So yeah, this is doing it again some couple of times, just to be double sure that it's updated. It's updated, so we'll skip it. I'll show you how the placement works also. So what I'm doing is I'm getting a status of just one of the resources to just reiterate what we talked about. So in the status, if you see, there's a list of clusters, and it mentions that in cluster number 1, the resource has been propagated. That's a list of the clusters where the resource actually has been propagated and is being actively reconciled. So of late, we were able to get a feature which we call selector-based placement, and that basically is something like a label selector, where we apply a label on the cluster and we apply a label on the relevant resources. So based on the label available on the clusters, or whichever clusters are labeled that way, the resource is actually propagated only to those clusters. So I have just applied a label region is equal to EU in cluster number 1. Now, I update the placement to specify a same label-based selector on the federated deployment. Now let's see the status. So the status says that now the resource is propagated only to cluster number 1, because that particular label existed on cluster number 1 only. Let's just try to get the resource from individual clusters. So for cluster number 1, the resource is propagated, it exists. Cluster number 2, the resource does not exist anymore, because it was not selected by the selector. So these are the 3 things I showed. So I was able to tell you that we are able to enable or disable the types that we want to say are the federated types without writing any code. We are able to upconvert or federate a given K8s resource as a federated resource, so that we call the federate feature. And we also have some enhanced mechanisms where we can control the overrides and the placement. So let me go back to the slides. And this is something, and reiterate the concepts in a brief. Maru will be talking about them a little in more details. So the whole architecture of federation is such that we say that we have a configuration, a type configuration, which basically deals with defining what federated API should be used by a reconciler to map to a target K8s API. And the API subtenets, we say, are template placement and overrides. And so there is a cluster configuration which can be attached to this. So there is something called join and unjoin using a tool, where we can tell the control plane that these are the clusters. At given point of time, we call them federated clusters. And we have something called propagation, which is enabled via our sync loop. And if the propagation is enabled, these, based on the type configuration, the resources which exist in federation control plane will be reconciled to individual K8s clusters. So using these basic things, there is a possibility of building high-level behavior, we already have some sample behaviors or sample implementations of the same, which is at the lower right-hand corner of your screen as a DNS service discovery and replica scheduling. And it's more to those implementations are more to showcase that what can be done with whatever we have been offering as the basic tenets. And there are more possibilities, or based on the user needs, a more custom scheduler or a more custom behavior could be built. So coming back to what we have been doing is we have enhanced tooling a little bit. Not just a little bit, we have enhanced tooling a little lot. So we have now full-fledged CueFed enable, which without writing any additional code, so we don't have to write any code to ensure that these APIs are, we can claim that these APIs or these CRDs we can federate, and if you create a federated resource, we'll be able to sync them or reconcile them. It's just a simple command, so if you say want to have a deployment in K8s, and you need to have ensure that it's reconciled using a federated control plane after you create a federated resource, all you have to do is CueFed enable. Federate is on similar lines, so federate is used to translate the K8s resources to, say, federated equivalents. We have overhauled the API, so last KubeCon update, these APIs were individual APIs, like there was a federated type. When I showed you the YAML, I mentioned that there is a placement, there is a template, and there is an override. So federated type is basically a template. Federated type placement is where I specified that this particular template should be propagated to these clusters. And the override is, I mentioned how exactly you can change a particular value or field in the spec in the target cluster. What we have done is, it seemed a little problematic for the user, because a user dealing with so many APIs might get overwhelmed. And the initial reason we did this was mainly to have some RBAC-based controls on placement, for example. So a user can define only the template, but maybe does not control the placement or does not control the override. But the similar facility is available, or similar functionality is available using using different mechanisms. So what we have gone ahead and done is that we do not necessarily need them as different resources. We have made them as a single API, a unified API. And so inside the unified API, nothing else changes, but the same tenets are placed within the single resource. One more thing was missing was status from it. So I showed something about the status, the propagation status, getting the details about reconciliation. If some problem happened, say there might be so many clusters, there might be more than 10 clusters in some cases, or some users have reported as much as 100 clusters also while federating. So it's highly inefficient to go to individual clusters and figure out if my resource actually is there and what's the status of that resource. So this status is important in that way. We were missing that, so we have updated that. So it provides a consolidated propagation status, and it also additionally lists problems if there has been any. So there is a set of APIs. So we have a good set of APIs right now in the API surface, but there are some APIs which we consider them as core or central to the whole project. Those set of APIs, we also have ensured that we do all the checks, and if there were some places we were not necessarily compliant to the K8s API standards, we ensure that there is a compliance. So we have ensured that we are compliant to Kubernetes API right now. So this thing is fully compliant. In terms of future work, so So what we are soliciting right now is, we say that we are almost beta, and we are soliciting is user feedback. And we have a couple of users in terms of the sponsoring companies, but we probably need to get a wider user base who can give us exact feedback as to what probably is something missing or we need to update. So the next steps that we think might be useful is the improvement of the usability, improvement of documentation. So we have provided some mechanisms where we can translate the K8s APIs. We probably will try to improve that. For example, we are thinking of an Helm plugin, which can on the fly convert K8s applications and deploy them as federated applications. So you don't necessarily have to change anything. You have a Helm chart, and you deploy it onto a federation control plane, and you already have a number of clusters associated with this control plane. So effectively, you are deploying applications across them. And you can have an automated behavior controlling this deployment also. We are also thinking of a user-facing high-level API. So what we mentioned, that these are low-level tenants. We are thinking of a high-level API, something very similar to AppCRD that exists in K8s as of today. In earlier slide, I mentioned that currently we have a push-based activity reconciliation. We are also thinking other possibilities where maybe a pull reconciliation or more static approaches like a GitOps model. Okay, so for a deeper dive into the details that I mentioned, Maru will come here and talk about them more. So you want this? Give us 2 minutes.
Hello? Okay. So my name is Maru. I work for Red Hat. I've been working on CubeFed for a really long time, so I'm going to try to give you some technical background as to how it actually functions under the hood, and maybe give you some insight into directions you could take it, or we could take it, depending. So the features we're specifically targeting for beta are being able to register a cluster to the control plane, being able to enable management of an arbitrary Kubernetes type, and convert resources, as he was demonstrating, from a Kubernetes resource to the federated equivalent. There's a lot more detail in how we're actually going to manage member state using the results of those operations, and I'll go into some detail in subsequent slides. So the first thing we do is we need to register a cluster. We need to identify a Kubernetes cluster to the control plane. So you could do this manually. It's just API types under the hood, but we provide a command to make it easy on you. And all the command basically does, given sufficient authorization to the cluster that you want to add to the control plane, it will create a namespace and a service account in that namespace with sufficient privileges to manage the resources that you care about. In the case of a namespace scoped federation, that'll be actually localized, but in the case of cluster scope federation, where you can manage any resource in that cluster, we're actually going to be granting cluster admin, and we'll talk about the implications of that later. So once you've created that service account, you create a CubeFed cluster resource, and that basically defines all of the information you'll need for managing those resources. The API endpoint, the CA bundle, that's optional, but and then we'll actually take the token used by the service account and we'll store it in a secret locally. And that allows the controllers in the control plane to access the cluster with full privileges. So given that you have registered a cluster, you need to be able to actually define the configuration you want to manage in one or more clusters. So the tooling that Irfan didn't actually demonstrate but alluded to is CubeFed CTL enable. And that's responsible for configuring the control plane to be able to manage a given Kubernetes resource in the member cluster. And similar to join, it's actually just creating API resources. So this is entirely dynamic. The first thing it's going to do is it's going to create a federated type CRD, which is going to be the equivalent of the Kubernetes type. So for an example, for deployment, you would create a federated deployment. It also creates a federated type config. And this includes the details of both the target Kubernetes type and the federated type. And for reasons will become clear in subsequent slides, I'm just giving you sort of the details of what, and I'll explain why it's useful subsequently. So the specific details that it's capturing are the group and the version and the resource name. If you're only using kubectl or generated clients, this might be a little bit foreign, but under the hood in Kubernetes, those are the three values that allow you to make a call and access a given API. So we're storing those as just the basic data. So the group, for example, like deployments would be apps, the version would be v1, the resource name would be lowercase deployments. So we store that information both for the federated type and for the target Kubernetes resource. So I'll just, a bit of a refresher because Irfan sort of alluded to this, but a federated type consists of three fields: the template, which defines the common form of the resource that you want to exist in however many clusters. It defines the placement, which clusters that resource should appear in. You can define placement both explicitly via cluster name. And when I say cluster name, I really mean the name of a CubeFed cluster that we created with join. And you can also use a label selector. Overrides, per cluster variation. I mean, essentially, it's a key value mapping. You could do spec dot, trying to think, maybe if you're dealing with a config map, spec dot data, and you could provide a map that you wanted to replace on a per cluster basis. And so it allows you to have one resource representing the resource in multiple clusters, and then where variation is required, you use overrides to define that variation. I'm going to highlight federated namespace because just like namespaces in Kubernetes, federated namespaces need to be a little bit special. Namespaces in Kubernetes are the only container. There's no other resource that can contain other resources, and it's not possible to create one. It's really built into the type system. So the consequence of that is we treat federated namespace a little bit special. For one thing, we don't actually create it as a container because we can't. So we actually put it as a namespaced resource, which is a little bit counterintuitive. The reason we did that is to enable maybe easier manageability. If you're an application developer, maybe you don't want to have access to a cluster scoped resource, a federated namespace. If you have full access to your namespace, you could create a federated namespace that controls propagation of the contained resources without administrative oversight beyond getting control of that namespace. The other sort of interesting aspect of federated namespace is its placement, like the list of clusters or the cluster selector you define for it, actually influence the placement of all of the contained resources. So there's a couple different ways you could use this. You could define a selector that selected all clusters, in which case each resource could define whatever placement it wanted, and it wouldn't actually be constrained by where the namespace went, because the namespace is going to be everywhere. You could also use it as a way of defining where the application goes by having every single resource, every federated resource in the namespace selecting all clusters, kind of the reverse of what I was talking about. And then the federated namespace placement actually would define which clusters that application was propagated to. And rather than having to manage placement on a per resource basis, you could actually do it on the basis of the namespace, which is arguably a lot simpler. So as Irfan demonstrated, we kind of try to make it easy to convert resources from a Kubernetes form to a federated equivalent. Rather than having to have you write them manually, we have a command that does it for you. It's pretty straightforward. It's just simple YAML conversion, embedding the contents of the original resource as the template of the federated resource, and defaulting to selecting all clusters. The only maybe interesting thing is you can federate the contents of a namespace, so rather than having to specify individual resources, if you had an application in a namespace, one command can convert the entire thing as per his demonstration. Now, this is going to get a little bit more complicated, but hopefully it'll tie things together. When we talk about propagation, we're really talking about reconciling resources and member clusters with a federated resource. And the way that we do that is we take the federated type config that we saw back in CueFed CTL enable, and the way that it captures the API details of the two resources. If an FTC exists, we have a controller that creates a sync controller that then watches all of the member clusters for the configured target resource and watches the host cluster for the configured federated resource. And then it can make sure that the state of the federated resource is represented in the member clusters. The nice thing about this is you never have to write any code. Previous iterations of federation actually required you to hand write a controller for every single type. But because of the way we're doing this all dynamically, you can actually federate a resource that didn't exist when we wrote this code and have it work properly. A little bit of detail about the API interaction. It kind of relates to the group version resource name that we saw earlier. GVR allows you to make an API call to a Cube API server, but the question is, how do you actually deal with that in code? If you've dealt with generated clients, like the official Cube clients, you actually have a Go struct that will be returned, which isn't particularly useful if I don't know the type and it didn't exist when I wrote the code. So we actually leverage something called unstructured, which is part of the internals of Kubernetes. They actually use it as the basis for the garbage collector and other sort of low-level system functions, because for the same reasons, they need to be able to interact with resources that they don't have any knowledge of. It'll have a standard interface like metadata, but it won't have any knowledge of what is in the contents of the type. This has the disadvantage of there's no type safety. You're basically just dealing with maps of interfaces, not dissimilar to maps of dicts or dicts of dicts in Python or something like that. But because we have this very consistent form across federated resources with template, placement, overrides, it actually works quite well. The only other sort of interesting detail about the sync controller is because lacking type details, we don't actually have an easy way of performing comparison. We can use the federated resource to generate the desired form of a resource that should exist in a given member cluster. But then how do we know whether it's current? We don't have any basis for comparison because we don't actually understand the internals of that resource. So we've developed a versioning scheme, I guess, for lack of a better term. So we look at the template field, we look at the override field, we hash those contents, we perform a creation or an update on the API, and then we record the resource version or the generation, depending on the type of resource. And then if we see those same values and that same value in subsequent comparisons, we're good. And if they differ, then we have to perform an update. That may have been too much information, or maybe it was interesting. I have no idea, but that's it. You're done. That's the hard part. So we have time for questions. Hopefully, this has been interesting enough that you actually have questions. I've listed out some common questions that I get asked a lot in case it's interesting to you, but I'm not going to answer them unless you actually ask me. And if you're not interested, that's totally fine. Do you want to? Oh, you can't. Can someone run around with a microphone?
So just to get in my mind clear, I'll start by stating what I think I've understood, and hopefully we can start there. So the way we've worked, let's say we've got three Kubernetes clusters, and we can have a federation control plane which could be completely separate, or it doesn't need to run in one of these Kubernetes clusters.
It can for convenience, but it does not have to.
So we've got our command and control center, and there should only be one of those, because as far as I'm aware, you say to the commander, you say to CubeFed, I would like this federated deployment, and then it pushes those configs into all your clusters which you've joined into the federation control plane.
Correct.
So it's not like a pull-based thing where they're obviously the kubelet speaks to the API server and says, what should I be running? And then it then runs it. So this is so you're pushing to those and then leveraging the existing structure. So then I guess the first question kind of appeals to me quite a lot, which is how are you dealing with RBAC? Isn't it a route? Is it a route into, is your federation control plane a route into all your clusters effectively then?
Correct. So effectively the CubeFed control plane, that's where you'd be enforcing RBAC permissioning. But as far as like permissioning in the clusters themselves, it has root effectively. And so it's like you control it here instead of there. I'm not saying it's not dangerous, it's just one strategy.
Okay.
So in answer to, or something that's often an answer to like, well, I don't want to give cluster admin, like what are my options? What we've implemented is we call it like a push mechanism. I mean, if you're familiar with the GitOps model, you'd be defining configuration in a Git repo, and you'd have a local cluster local agent that would still have cluster admin, but it would be localized so that if it was compromised, only that cluster is compromised, whereas if your control plane cluster was compromised, then all your clusters are compromised. So we haven't implemented it because we don't have people yelling at us to do so, but it's entirely possible that you could use CubeFed as a control plane only to generate configuration. You'd use the federated types because maybe it has some convenience or you like working with the Cube API. You could generate that configuration into a Git repo and use one of the popular tools to apply it locally.
So you generate the templated config and then you use a tool to apply it. So that's kind of almost going like you've got Tillerless Helm, which is templating it and then applying it using your local permissions. It's kind of a similar.
It's kind of similar, only it's more focused on like defining configuration for multiple clusters versus just defining it on an application basis. But similar concept, yeah.
So do you still, if you want to have a highly available federation control plane, you're still going to have to you're going to have to do a manual failover, I guess, because what happens if you've got two federation?
You don't really want that, yeah. They tend to fight with one another. Failover, it's the challenge with building an API and centering it around the Cube API is it's not really possible or feasible, at least not that I'm aware of, to HA a Kubernetes like cluster. Like you can do failover, you can do disaster recovery, but like a live failover, it's really hard to synchronize etcd beyond the boundaries like of geographical, like the latency requirements are kind of complicated. So we're kind of bound by that, but I will say like what happens when CubeFed goes down, that's a common question. Generally, all your workloads keep running in the same way that all of your workloads keep running if the Cube API in a cluster goes down, at least hypothetically, because your nodes are still running. So your clusters are still running even if the CubeFed control plane, you can't make changes, but things still work.
And one final question before I stop hogging all the questions. So if I've got a federated deployment, is it going to federate, is it just going to splat the deployment everywhere? Is it going to roll it to, can you roll it to a canary cluster and it goes, whoa, that's broken, I'm not going to roll that anywhere else?
So we don't offer the ability natively to do that. However, when we've alluded to higher level functionality, what CubeFed is a way of defining configuration, having it be applied in a consistent way. And it looks really simple. Unfortunately, it's a little bit more complicated. Sorry. So the challenge is like, our goal is to try to get people interested in the idea of using Federation as a lower level sort of mechanism for applying configuration, like kubectl apply, but for multiple clusters, that kind of thing. So you're going to build, like, if you wanted to do like a blue-green deployment sort of thing, you would have a piece of logic that would program like the federated deployment to go to that cluster, and if it's healthy, then you apply it. Or maybe a better example would be you have a healthy deployment, you want to upgrade it to a new version, so you apply it, an override to just that cluster to use a new image. If it proves healthy, then you can actually change that in the template and remove the override.
So effectively, you're providing a set of primitives that other tools will need to be built on to kind of get to this.
Correct.
This sort of approach. Cool. Thanks.
Correct.
Hello. Would CueFed be suitable for setting up cloud bursting? For example, I would have a deployment in one of my clusters. I would federate it with CubeFed and apply a horizontal pod autoscaler on my deployment. And if I scale it up, would my pods go to the other cluster?
The pattern that you just mentioned, it's one of the really possible high-level behavior, what he's talking about. And as part of the first implementation, which we call Federation V1, there actually is a prototype cloud bursting HPA implemented. So there is a possibility that you can implement or program your HPA, which we call federated HPA, into a cluster such that it is configured when it runs out of capacity in one, then only the replicas are moved to the other clusters. So it's certainly possible.
Hi. I was wondering if there's any reason why you have the overrides and the conditions in one object compared to having multiple. I sort of see it could be a good thing to have a federated override as a different resource so that you don't, if you only want to override in one cluster, you don't touch the resource for all the other.
So is the concern that if you edit the resource, you'll potentially screw it up for all the other clusters? Or like the override can be applied on a per cluster basis?
Yeah, sort of if you generated a federated resource with some overrides in Helm or something, where it would be more of a complete override.
Mm-hmm. So you're talking about you'd prefer like a separate resource?
Yeah, more wondering if it was considered. I don't know if it's a good idea.
We actually moved from a separate resource to an unified resource. So separate resource, what we felt was too much to handle or the number of resources in the control plane itself, where a user wants to control a single resource in the target resource, and we have say 4 resources for controlling single resource. It's too much for a single user. So that's why we have placed all of them together. And as you mentioned, the override is not something which you specify for, say, you specify something and you store it up for rest of the cluster. So override is per cluster. So you specify that I want, just like a list where you specify this for cluster number 1, for example, and separately fields are there for this.
Okay, thanks.
So you were discussing this a bit about the second one, when CubeFed goes down. So the clusters are fine, but when you deploy the CubeFed again, is it just as simple as joining the clusters back again and everything is working, or is there are there more steps on how this works once the control plane is down?
I don't think it's so much about adoption. So if I lose the control plane, the expectation is there's a disaster recovery strategy using like Valero or something like that, so that you would lose it, you would bring it back up over here. There's no cluster-specific state outside of the resources. So the CubeFed cluster and the associated secret, it doesn't matter which cluster it lives in, it still allows the same access modulo like network connectivity.
And the second one, okay, now it's gone, but about the service discovery, we tried to set it up with this core DNS and external DNS and all of that. There are like a couple of layers and steps that you have to take. And we killed one of the cluster to see how it all works. But essentially, we found few problems with how core DNS works. So it wasn't deleting the IPs of the cluster that we pulled down, and there was some unexpected behavior. So I was wondering if there are like any best practices on how to set up the service discovery.
Are you talking about the service discovery that CubeFed or Federation has supported like for quite a while, or are you talking about something else?
I think it's supported. I think you support both using the cloud, the Google Cloud DNS as well as core DNS and having.
About the feature which is available, DNS-based service discovery, which is available as part of CubeFed.
Yeah, yeah.
Yes, there might be possibilities that in certain scenarios that feature might not work. It's not something that we are right now driving towards beta. It also has some inherent problems in itself. For example, you mentioned about some entries for a cluster which has already gone down, not being updated. A very peculiar use case is that if the clients which are looking at these applications with those entries, if it's a dump line, it's not refreshing, it's not figuring out what's happening, then it will actually keep the older IP intact with it. So that refresh cannot happen at the client level. And it will live until the time out for that entry is. So, and there is no real solution for that. So that is also a reason that we would actually now be looking at other projects which can provide similar networking use cases and figure out if we can have Federation and those projects work together to provide a similar solution.
So all that to say, like the solution that we've proposed in the past or has been included is not actually viable from a production standpoint. I think the motivation was originally is trying to extend the DNS-based model that Cube uses internally to be able to extend that to outside. But if you understand how Cube Proxy works, it's effectively like a poor man's load balancer, so that it's health checking the back ends and it will take them out of rotation if they're no longer healthy. But if you have an external DNS server that's not doing health check of any of the entries, then you have the scenario of not being able to fail over depending on what the TTL of the DNS client is. Whatever DNS client they're using, what the TTL is will determine how soon they discover like a new endpoint. So effectively, like, we're recommending that people look at other options that aren't DNS-based. We don't have something to give you with this project. It could be that we could work together to find like a generic load balancing solution, because really that's the ideal if you're talking about service discovery outside of a Cube cluster. You want something that can health check backends so that you can automatically fail over client requests as the backend becomes unhealthy versus at some random point in the future. And the other option, other than load balancer, is if you're talking about internal to internal, if you're using a service mesh, like Istio is promising the ability to do cross-cluster service discovery. I would be surprised if all the other service meshes didn't offer something similar. But it's really like there's many different ways to do it, and really depends on your use case and what sort of infrastructure you're dealing with, which is why we're kind of de-emphasizing it within this project, because it seems like it's a bit large for us to bite off. No more questions? Or any more questions?
Do you have any plans to make it somewhat easier to extricate yourself from a federation in a way. Like, for example, when I was testing out, I took over an existing namespace, effectively. So I have like cluster 1, cluster 2, namespace foo in both. I create the federated namespace with only cluster 1 selected as a placement. At that point, it deleted the namespace in cluster 2. I then panicked and was like, oh no, if I recreate it in cluster 2, it'll just get deleted. So I deleted the federated resource, so it deleted it in cluster 1 as well. Luckily, we have 3 clusters, so it didn't make a difference. But I was wondering, is there like plans to help, like opt out almost, if you need to?
So your horror story is not unique. We had another person, I think, with Huawei who reported the same problem, and it was kind of a long-standing issue that we somehow hadn't encountered because we're not proper users, I guess. But we were managing resources that we hadn't actually created, or like if you create a federated resource and an existing resource is there, and then you set the placement so it doesn't include this existing resource, it deletes it. So we've moved sort of beyond that by labeling resources that we manage, and we will adopt existing resources conditionally. Right now it's conditional across the whole control plane, but if you wanted to avoid the sort of scenario you're talking about, you could set a flag in the control manager that said, you know, don't adopt resources. And that would mean it wouldn't ever adopt existing resources, and if it doesn't own them, if it doesn't actually have a label that says I'm owned by Federation or managed by Federation, it won't delete them, it won't update them. So you can work around it today. I'm really sorry that that wasn't the case in the past. And in terms of like extricating yourself, I was kind of thinking you were going down the path of like, I have federated resources, I want to defederate them. That is something that should be easy enough to implement. Like we have the CubeFed federate, which converts, you know, this to this. I mean, it's a pretty simple transformation to take a federated resource and just create a normal cube resource out of that if that's what you're asking for.
No, I wasn't asking that. No. I was just more talking about like how do I stop a resource from being controlled by the Federation control plane, which is what you were saying about the labels.
So I mean, you can, if you had an existing resource that was managed, you could actually remove the label manually, and that would have the same effect. Or just kill the control plane. That would also work. Any further questions? No? Well, then you get some time back. Thanks all.